Showing that this equation is a union of two cones entails the procedure below. First, I need to solve for y to the power 4. Next, I take the square root on both sides. I identify y to the power 4 as y squared all squared. I use the absolute value definition of the square root of a function squared, and then now I obtain this result. Now, the absolute value of x squared minus 4x is either x squared minus 4x if the x squared minus 4x is positive, that is x is in the interval I, or it is negative into x squared minus 4x, that is 4x minus x squared, if the x squared minus 4x is now negative, meaning x is in another interval j. So let's take the first case when x is in the interval I. We don't actually need to know this interval, okay, but all we want to show is that this is the union of two conic sections, this equation. All right, so x being in the interval I, it means that y squared is actually 4 into x squared minus 4x. We can complete the square on the right hand side, that is x squared minus 4x can be written as x minus 2 all squared minus 4. We distribute the 4, which is the multiple, inside, and we get 4 into x minus 2 all squared minus 16. Now we can add 16 on both sides, and we subtract y squared on both sides, and then we get this equation. We can now divide all through by 16, and then we are going to get that x minus 2 all squared divided by 2 squared minus y squared on 4 squared equal to 1. So this is the equation of a hyperbola which is centered at a point 2, 0, with the y-axis being the major axis. So I leave you to do for when x is in the interval j, and believe me, you're going to get an ellipse, okay, and you need to give the characteristics. So you see that that equation is the union of two conic sections, a hyperbola and an ellipse. Thank you guys for watching, and see you in the next video.